In this video, I'm going to do two questions based on factor theorem, two very important questions. First of all, you need to figure out what is a factor theorem. Let's say there is a polynomial px, and if I say that, say x plus a is a factor of this polynomial px, in that case, p minus a, that means 0 of this, will be equal to 0, right? So let's see what does the question says. In this question, we are given x minus 3 as well as x minus 1 by 3 are the factors of this polynomial px square plus 3x plus r. We need to show p is equal to r. Ordinarily, we take the polynomial as px, but here p itself is a arbitrary constant in this. Therefore, we'll be considering, let's say, this polynomial I'm taking as, say, gx. I took this polynomial as gx, or I can take fx. So I took this polynomial as fx, which is px square plus 3x plus r. Now what you can see that since x minus 3 is a factor of this fx, this implies that f3, right? The 0 of this is x minus 3 when equated with 0 is 3. So f3 is equal to 0. That means we are going to replace wherever there is x with 3 over here, and that will be equated with 0. So this is p bracket, this is 3 square plus 3x, that means 3 times 3 plus r is equal to 0. I can simplify it and write it 9 times. This will give you 9 times p, because 3 square is 9, right? Plus 9, right? I wrote 3 square as 9, and 3 plus 3 is 9 plus r is equal to 0. Say I mark this as equation 1. Now you can say that even x minus, we say, what do you see that even this is given that x minus 1 by 3, since x minus 1 by 3 is a factor of this fx, it implies that f 1 by 3, right? Because the on equating this with 0, we'll get 0 is equal to 0. Now we are going to plug in everywhere as x replaced with 1 by 3. So let's say what we are getting, this we'll get p times, this is p times 1 over 3 square plus 3 times 1 over 3 plus r is equal to 0. So this is what 1 by 3 square is 1 by 9. So that is p over 9. And here 3 and 3 get cancelled. So we'll get 1 here plus r is equal to 0. And say I mark this equation as 2. So now you have to see these two equations. That is equation 1, this one. And now look for this final part. That is this second equation here. What you can see at in both cases, the RHS is same. We have the same RHS here, that is 0. So from 1 and 2, what we can say here? From 1 and 2. That is from 1 and 2. I can equate these two. So I'll say that this is 9p plus 9 plus r should be equal to 9 over plus 9, p over 9 plus 1 plus r, right? This would be equal. Now what you can see here, we can cancel r and r. This will give us the value of p. So I am transposing 9p minus p over 9 should be equal to 1 minus 9. Taking LCM, it will be 81p minus p over 9 should give you minus 8. So this is what? This is 80 minus 80 times. And if I transpose 9 to the other side, So to see 81 minus 1 is 80p, and 9 if I transpose on the other side, it is minus 8 over minus 8 into 9. Finally, we are going to divide this by 80. So I'm going to get as minus 9 by 10. Now we got this as 9 by 10. And for the remaining part, I'm doing on this side. So let's erase a part of it. So we got P, the value of P we got as minus 9 over 10. Now in order to find Q, what we are going to do is to replace one of this equation. Like in the equation 1, we had 9P plus 9 plus R is equal to 0. So what I'm going to do is to replace this P, the value of P, with 9 by 10. So I'll write this as 9 multiplied by minus 9 by 10 plus 9 plus R is equal to 0. So this is giving us 9 into 9 is 81. So minus 81 plus 10 plus 9 plus R is equal to 0. Now further it is minus 81. If I take LCM, it will be 90, right? 9 into 10 is 90 plus R is equal to 0. With further simplification, I'm getting this as 9 by 10 plus R is equal to 0. And if I transpose 9 by 10 on the other side, I'll get this as minus 10, minus 9 over 10. Now check here, we got this as 9 over 10 and P is also 9 over 10. So we just need to see that we got P is equal to R, right? Just from these two, we say that P is equal to R. That is what we have to prove in this. The next part is very similar. Let's see how can we do this. Similar to the previous part, we have x minus 2 and x minus half are the factors of this polynomial. So we'll start like this. Since I can take this polynomial, I have to first take this polynomial. Say if I take fx as px square plus 5x plus r, right? And we can start like since x minus 2 is a factor of fx, therefore the 0 of this is what? 2. So I'll say that f2 is equal to 0. Now I'm going to replace f with fx, right? X has 2, so I'll get p bracket 2 times 2 square plus 5 times 2 plus r should be equal to 0. So we may not show this right directly. This is what we 2 square is 4, 4 times p plus 10 plus r is equal to 0. So I'm going to mark this as equation 1. Now in the next part, here also we'll write since x minus half is a factor, that's for the question is given that it is a factor of fx. So like the previous part, I can say that f half, like the 0 of this is half, is equal to 0. Now we are going to replace this with half. So this is p times half square plus 5 times half plus r is equal to 0. Now we can first solve it. Half square is 1 over 4. So this is p over 4 plus 5 over 2 plus r is equal to 0. Now compare these two. This is say equation 1. We need to see in this equation 1, we have RHS as 0. And when you see equation 2, say if I mark this as equation 2, here also RHS is 0. So we can say from 1 and 2, from equation 1 and 2, we can equate these two. So I'm writing 4p plus 10 plus r is equal to P over 4 plus 5 by 2 plus R. Now we can see here that R and R get cancelled. And in order to find the value of P, I'm transposing P to the left, P terms on the left hand side, 5 by 2 and the constant on the right hand side. This is 4 into 4 is 16. 16P minus 1P is 15P. 15P over 4 is equal to, if I take LCM, this is 5 minus 20, which is minus 15 over 2. So I took an LCM here, that is 5. If I take LCM, so it's 5 minus 20, which is minus 15. Now, in order to get P here, we'll simply transpose. This is 15 over 2, that multiplied by 4 over 15. So we can reduce here. This 15 and 15 get cancelled. 2 1 times, 2 2 times. So we got the value of P. Here we got the value of P as minus 2. Now what we are going to do here next is to replace the value of P in any of these equations. Let's say I choose to place in the first equation. So what I'm going to do is to replace the value of P in this equation, say the first equation, and say what we are getting the R as. So they say this is 4 times P, which is minus 2, plus 10 plus R is equal to 0. This is how much? Negative 8 plus 10 plus R is equal to 0. Minus 8 plus 10 is positive 2. So 2 plus R is equal to 0. This implies R is equal to minus 2. So what we proved here, that P is equal to R, right? We got P is equal to R. This is what we need to prove.